All right, this is a find the mass problem, right? Okay, so let's see. This first part, this always gives people great consternation, right? You exert 60 newtons on the car and it moves at a constant velocity. It doesn't accelerate, right? That means that there's a friction force of 60 newtons, and here's why, okay? If I can exert 60 newtons this way and it doesn't accelerate, there must be no net force acting on it. That means there's a force the other way. These guys are equal but opposite, right? Of 60 newtons this way. Negative 60, positive 60, right? They add to 0, so it doesn't accelerate. If I exert more than 60 newtons here, it would accelerate to the right, and if I exert less, it would actually, if it was moving, decelerate. Okay? So that's what we mean by this, is just we can exert that force, it moves at a constant speed. That's the friction force, right? So let's solve this problem with that in mind. Okay, so here's this little cart. We're exerting 80 newtons on it, right? The 60 Newton friction force is still there, right? And then, oh dear, we've got a little Suvat problem here. 2 meters per second in 100 seconds, right? So acceleration is change in velocity over time. So 2 divided by 100 is 0.02 meters per second squared, right? I guess with 2 sig figs, we have to say 0.020. Okay, so now we're set. We're going to go, this is positive, this is negative, right? So 80 minus 60 equals m times 0.02. Well, 20 equals m times 0.02. 20 divided by 0.02 20 divided by 0.02 is 1,000 kilograms. But 1,000 has actually 2 sig figs, right? So this is a cop-out. To write it with 2 sig figs, you have to go 1.0 times 10 to the third. I just got lazy. You could. Some people say you can put a little bar like that over it, but I don't buy that.